The Earth is the only place in the solar system known to have life. And this is thanks to a combination of the right conditions. Its presence in the Goldilocks zone around the Sun, which allows for moderate temperatures and liquid water to exist. Its atmosphere, which shields us from solar radiation and distributes temperatures sufficiently. And its protective magnetic field, which protects us from both solar and cosmic radiation. On Earth, all of these factors came together in just the right way for life to begin and continue for billions of years. However, this raises the question of how survivable, if at all, the conditions on other worlds in the solar system truly are. There tend to be several reasons why life cannot exist on these other worlds, so let's explore some of them and get a sense for just how lucky we are on Earth. We'll start close to the Sun with planet Mercury. Mercury is the closest planet to the Sun, which immediately raises red flags concerning the question of habitability. The Earth is 1 astronomical unit, or AU, from the Sun, which is equal to about 150 million kilometers. In contrast, Mercury is only around 0.4 AU away from the Sun. As a result, Mercury is exposed to vast amounts of solar heat and radiation. Its surface temperature at the equator can rise as high as around 430 degrees Celsius. However, because of Mercury's lack of an atmosphere, the surface temperature varies based on where we stand on it. If we move to the poles, we'll find that the temperature doesn't rise above negative 93 degrees Celsius, regardless of day or nighttime. This is caused by two things: Mercury's deep craters and its lack of axial tilt. Both of these factors combined mean there are regions close to the poles within craters that never see sunlight. They're covered in darkness 24/7. Also caused by Mercury's lack of an atmosphere is this aforementioned abundance in craters, as the surface has no protection from these impactors. Venus, being the second planet from the Sun, may at first seem to somewhat vindicate it from the same problems as Mercury, given that on average, it's about 0.7 AU from the Sun. This is 70% the distance from the Sun as Earth is. However, Venus is notoriously the most extreme planet in the entire solar system, and a big reason for this is its thick atmosphere. This atmosphere is composed of almost entirely carbon dioxide gas, with small amounts of nitrogen and trace amounts of other gases. No molecular oxygen. Furthermore, if we go through the clouds and look at the surface conditions, we see something even worse than Mercury. The average surface temperature is a blistering 460 degrees Celsius, considerably hotter than that of Mercury. And this is thanks to the fact that carbon dioxide is a greenhouse gas. What this means is that Venus's atmosphere essentially acts like a giant blanket, trapping heat at the surface. This is also the reason Venus's night temperatures stay at the exact same despite its 243 Earth day rotation period. The air pressure at the surface of Venus is also extreme, being about 100 times higher than the sea level pressure on Earth. Thanks to these severe conditions, any previous attempts to run lander missions on Venus lasted at most a few hours before the landers melted away. Skipping Earth, we come to Mars, the fourth planet from the Sun, and the most well-known in popular culture, not only for its apparent similarity to Earth, but also for prospects of human settlement. However, it is important to recognize that Mars has several serious problems that humankind needs to address before we consider even touching the surface. For starters, we're beyond Earth now, so we're starting to get quite far from the Sun. As a consequence, One of Mars's most glaring features is its consistent extreme cold. Many rovers have been sent to Mars over the years to gather data about its climate, so we have quite a good idea of what it's like. Over the year, typical Martian daytime highs range between -20 and 0 degrees Celsius, which is of course not unheard of. I'm a Canadian, and I experience these temperatures regularly during wintertime. However, nighttime temperatures on Mars frequently drop below -80 and sometimes below -100, temperatures which are far colder than what we experience on Earth. These temperatures, coupled with Mars's lack of precipitation, means that the most similar place on Earth to Mars is Antarctica. Another major problem with Mars is its severe lack of an atmosphere. There seems to be a tendency to underestimate just how thin Mars's atmosphere is, and this could be due to photos we see of its reddish-brown skies from the surface. The main source of this color is actually iron oxide dust suspended in the air. Mars's atmospheric pressure is the opposite extreme from Venus. It is only 0.6% that of Earth's, which is practically a vacuum. What little atmosphere Mars does have, though, is almost entirely carbon dioxide gas, with only trace amounts of oxygen. This lack of an atmosphere also opens the surface of Mars up to all kinds of hazards from space, such as radiation and meteorite impacts, as evidenced by its heavily cratered surface. We've now reached the outer solar system, and we'll explore Titan, one of Saturn's hundreds of moons. Titan is among the most studied moons in the entire solar system. The most obvious reason for this is its uniquely thick atmosphere, which other moons lack. Taking a closer look, however, we see just how severe this world really is. For starters, as mentioned before, we're in the outer solar system, where the sun is much weaker. On average, Titan is around 10 times further from the sun than Earth is. What this means is that, taking Titan's clouds into account, noontime would only be as bright as dusk on Earth. Thanks to this distance, it shouldn't be surprising that Titan is an extremely cold place. The average surface temperature is around -180 degrees Celsius. These temperatures allow Titan's organic compounds, like methane and ethane, to exist as a liquid on the surface. In fact, Titan is known to have a vast network of rivers and lakes, composed mostly of methane and ethane. More about Titan's atmosphere. It's composed almost entirely of nitrogen gas, with small amounts of methane and hydrogen. The atmospheric pressure is actually higher than that of Earth, being 1.5 times higher. However, unlike Venus, this pressure is survivable and won't crush a person. But attempting to breathe in the air here would not only cause your lungs to freeze instantly, but immediate asphyxiation from the nitrogen. Our last stop will be dwarf planet Pluto, formerly the most distant planet in the solar system. Like many of these worlds in the outer solar system, the main problem with Pluto is clear. It's just too cold. On average, it is about 40 times further away from the sun than Earth is. At this distance, the sun appears as merely a very bright point of light. Its average surface temperature is -230 degrees Celsius, with very little variation between daytime and nighttime temperatures. This is only 43 units above absolute zero, and these cryogenic temperatures lead to some interesting features on Pluto's surface. It is covered with glaciers, mountains, and craters, which are made primarily of nitrogen ice, because it's cold enough for nitrogen to exist in solid form. There is also water ice on the surface, but because of the conditions, it behaves like rock. As for its atmosphere, it's extremely tenuous, far thinner than Mars's atmosphere. The little atmosphere it does have is composed almost entirely of nitrogen and a trace amount of methane. It's essentially a vacuum, offering no breathable air or any protection from the hazards of outer space. Pluto's atmosphere is uniquely extreme in that it actually changes throughout the Plutonian year. Because its orbit is not perfectly circular, Pluto's surface will actually sublimate and become part of the atmosphere when Pluto is closest to the Sun. And when it's furthest from the Sun, Pluto's atmosphere deposits on the surface as nitrogen ice. This cycle continues every Plutonian year, or 248 Earth years. We've only seen a small sample of the hostile places that exist in the solar system. But the point is clear: that life evolved to exist on Earth, and on Earth only. The next time you step outside in the summertime, perhaps take a moment to be thankful that it's not literally as hot as an oven. Or when you step outside on a winter day, be thankful it isn't cold enough for the nitrogen in your lungs to freeze into ice. The Earth is a special place, and comparing it to the alternatives makes this crystal clear.